So, what did you think of this week's stuff, the lesson?
Might as well put a background on. I thought it was pretty good. What'd you
Pretty
think?
good. I remember there's a couple things that kind of threw me off. Like, I mean, it's kind of the same idea as everything else, but what is it? It's like there's like an upper bound and a lower bound, or there's like a small number and a big number or something.
Oh, a confidence
And
interval?
no, I don't think it's a confidence interval. It's a let me look. Okay, so for this, what exactly no, let's see. Yeah, what does the DF mean, like, when it comes to this?
Degrees of freedom.
Yeah, because
well, that probably, so like an ANOVA test, I think it was saying that it's basically like doing a bunch of two sample t-tests
okay,
between every set that you have. That makes sense?
right, to see how see if there's any difference between the three averages or four or whatever, the multiple averages.
Yeah, so I'd imagine that the DF comes from there. I don't know exactly how.
What does it tell us though? Like, why do we care? Do you know?
Degrees of freedom. Why did we care before?
Yeah, I don't know actually, because that's just the n-1, right? Or is that something else?
Yeah, well, like when we were doing the t distribution, the shape of that t distribution is based off the degrees of freedom.
Okay.
And so the degrees of freedom, from what I understand, is one of those variables that's there to help us when we have a sigma unknown. And so it's basically helping figure out what the distribution should be based on how many, because it's based on how many samples you have, right? That's what influences it.
Okay.
And so based on how many samples you have, I think you're kind of making a guess at, well, mathematically making a guess at what your standard deviation would be.
Gotcha. Okay.
That's
I'm looking at the.
Yeah, I don't know exactly, but that's kind of what I understand and how it fits together.
Okay. Right now, I'm looking at the ANOVA spreadsheet thing, and where it says between groups, I happen to have three variables, and so it says between groups the DF is 2. So I take that to mean that since there's three variables, it's the whole n-1 thing, and you get 2. Then it says within groups, the DF is 42, and out of my three variables, I have I'm sorry, it's. Oh, yeah, it is 42. Huh. And then, so maybe I'm wrong. What I was thinking was between my three variables, I have, it looks like 45 cells filled. So I thought it was the n-1, but that would be 44. But 44 is the total. So I don't know if that's somehow where that number comes from, or I don't know. I'm just trying to figure it all out. Like,
I don't really know.
yeah. Oh well. As long as we can find it for the questions, I guess that works.
Yeah.
So it's actually kind of interesting. Some of the like in the, I don't know, the homework problems and the practice problems, where they give you data from what, studies or something, or observations. I don't know. Some of them are kind of interesting. Like, did you do that Nike one where they tried different shoes and?
Yeah, with the soccer players.
Yeah. So it's kind of interesting that the shoe could maybe help them kick better. So
yeah, it was interesting. I was kind of like
waiting. I was like, I wonder what the actual result will be.
yeah, like, does it really matter? Yeah.
It's kind of
And
cool.
something else I've kind of noticed is I'm pretty sure for every statistics class, like whether it's business or what is it, chemistry or
There's engineering statistics.
yeah, there's that, and then there's a sciencey one, and then also like a social science one or something.
Uh-huh.
But I think they use the same stuff, at least if it's online, because like the majority of the things they have us study are like about, illnesses or
Yeah, they just use the same course material.
yeah, like it seems like the exact same thing, just with a different title.
Uh-huh.
So
Yeah.
kind of interesting.
Sweet. Well, I don't know where Jason is.
Yeah, I don't know if I don't know if he's gonna show up today. Why does the drama one make that noise? Like, what noise is that? Like, it seems off.
Just a drama noise, like look behind you.
I guess so.
All right, let's do this thing.
Okay. Let's see. Okay.
All right.
You
So
have
I
yours
kind of
open
cheated
up?
while I was waiting for you guys to come on and started doing it. So
That's okay. That
we'll
works.
see if what you came up with is what I
Matches
found.
out. Okay. So number 3 says, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different from the others. True, right?
That's what I said.
Nice.
All right. What requirements need to be checked when performing an ANOVA hypothesis test? Sample means are all positive. Data in each group are normally distributed. Variances are equal in each group. None of the above, or B and C.
Okay. I think it said sample means have to be positive, right? Is that
Maybe. I said it was B and C. But that might
okay? So that would be data in each group are normally distributed and variances are equal in each group.
Yeah, because it said they have to be equal, which meant that the variances, which I was kind of confused with, because it's like they have to be relatively equal, which means that it's the whole that the largest variance has to be less than 4 times the smallest variance.
Yeah.
So I don't know if the variances have to be equal. That's what kind of throws me off, because I'm like, yeah, they're supposed to be close to equal.
Right.
But
Here,
the data in each group, let's see. I do think it's supposed to be, because that's where they were saying that you have to do the QQ plot type thing.
and that would show that the variances are equal.
That the data are normally distributed.
Oh, distribute. Right. Okay. Okay. Yeah, it might be that. Here, give me 1 sec. I keep getting a call, so let me take that real quick. Sorry.
That's all good. I'll go look it up. Requirements for
Okay. So in one of the videos, it says something about being positive, but it could be talking about something else though. Let me just pull that up real quick and see what that's talking about.
Okay. I did find this. Is that the right one? Yeah. So it says that there are 2 requirements for ANOVA, and it basically word for word says what's in those questions.
Oh, it said. Oh, okay. Yeah, let's go for B and C then. Yeah, no point in.
Yeah. I do remember something about that, but I think
talking about something else probably.
That's kind of.
Okay, so 5 says to check if each group is normally distributed, do the following. So didn't we say construct a QQ plot for each group? Or construct a histogram of all the data, or construct a scatter plot of the data in each group?
Yeah, I said construct a QQ plot.
Okay.
You could do a histogram, but I think, I don't know, it's kind of confusing because you have to kind of, well.
QQ plot seems like it'd be simpler to.
Yeah, it's definitely the most robust.
Yeah.
Way to do it. So, okay. So that's what I. Number 6, we assume the variance in each group is the same if the following happens. And I said that the largest variance is less than 4 times the smallest variance.
Yep. Nope. That's right.
And I was just at number 7, so this is where I was just trying to think.
Oh, okay. Let's see. So it says an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? Wouldn't it just be 4 pairs?
Let's see. I got 6.
6. Okay. So did you end up just writing it out, or is there another way to know?
Well, you can do a probability type thing. Like it seems like I think we can use combinations.
Okay.
Yeah, we could use combinations to do this. But yeah, I just wrote it out. So I knew we'd want to go 1, 2, 1, 3, 1, 4, right? So
right.
1 to, and then I said 2 needs to go to 3 and 2 needs to go to 4, but it already went to 1 and it doesn't need to go to itself.
Right.
And then 3 needs to go to 4, but then 4 is already gone to everything else.
Gotcha. So that comes out to 6?
Yeah, it comes out to 6.
So I wonder, let's see, so.
Yeah, how does he want us to enter this?
Yeah.
I think it's actually not as picky as it was. Like
in the beginning?
Yes, I think we could actually just put 6 in.
Just do 6? Okay. Okay. So do you know if there's like a math equation or something? Like, I doubt they'll do it, but maybe on a test it'll say like a large number, you know, like.
Yeah.
Is there a way you just plug it in?
Let me look up real quick. Pretty sure we should just do a combination.
Yeah.
Remember that?
Combinations.
Yeah, K combinations. I'm trying to remember what the equation is for it. All right, so it's n factorial over k factorial times n minus k factorial. So I believe k is the number of selections that we're making, and S is the group that we're making them from. So in this instance, K is always going to be 2, and then N is going to be however many comparisons we're making. So basically this would equal 4 factorial over 2 factorial times 2 factorial. And so what is that? So we got 4 factorial divided by 2 factorial times 2 factorial. That equals 6.
Perfect.
So, yep. I believe it's just because it wouldn't be a permutation because we don't care about the order. We just want to have unique pairs put together. So.
Right.
So yeah, that's the equation if you want it.
Okay.
Did you get what I said? What I said? Do you mean to say it again?
Yeah. Let me write that down. I'm just gonna grab a paper real quick.
Okay.
So how does it go?
So it's n factorial.
What is factorial again?
So that's when you multiply every number going down. So if it's 4 factorial, it's 4 times 3 times 2 times 1, but you don't have to do them 1. But it's just you multiply every number that's less than that number.
And then add it up?
No, you just multiply them.
Oh, right. Okay, gotcha. Okay, that makes sense.
Yeah. You do 4 times 3 times 2 times 1.
Okay. So n factorial times what?
It's n factorial, and that's all divided by, well, I don't know if you can see this.
Let me look at the screen real quick. Actually, right now, all that's showing up is your picture. Like,
that's weird. Oh,
like,
might have been because maybe if I took off my effects, you could see it. It's not really zooming in or focusing, is it?
Like right now, it's your normal photo, and then when you talk, it has like a circle, like
it comes out.
Yeah,
Should
like
see my picture soon. I can see my picture.
Weird. Maybe it's my end. I don't know.
Anyway, so yeah, it's n factorial over k factorial times n minus k factorial. So it's just an n factorial on the top, and then on the bottom you have k factorial times, and then it's n minus k in parentheses factorial. And then k in this instance is always going to be 2 because you're always comparing one against the other.
Right.
The only number that you change is n.
Cool. Okay, thank you.
Yep.
Okay. So 8 says the soccer shoes data has 6 groups, A, B, C, D, E, socks. These data can be found in the wiki load all 6 samples into the quantitative inference procedures spreadsheet or perform an ANOVA test, blah, blah, blah. So the p-value is 0.0809. Remove the socks data. What is the p-value? Round to 3 decimal places. Okay.
Let's see. Soccer shoes?
Yes.
Soccer shoes. There it is. Did you find it?
I'm searching around for it right now.
I can send it to you if you want.
Yeah, that'd be good.
I will do that. Copy link address. Come over here. That's not what I wanted. Paste. There you go.
Sweet.
Okay. So now let's bring this up. And that goes right there. And I want to select all of the A data. And bring 1. Select all of the B data. And variable 2. Select all of the C data.
So do we really need to first put in the socks, or just ignore the socks right now? Like, because they already told us what the p-value is, right?
Yeah. I guess we could, huh? But if we want to make sure we're doing it right, we could just see
that in
the same number. No, I didn't want to do that. select that variable. Ah, it isn't working. Copy. Paste values. All right. Let's see here. Over here, verify that the p-value is 0.089. All right, that's what I got. And then it says remove the SOX data. Removing the SOX data. Okay, did you get something yet?
One sec. So I'm looking for p-value. I have 0.309.
Yep, that's what I got too.
Awesome. Okay. 0.309. All right.
So it says the p-value, the number 9, the p-value always goes up when only one group is removed compared to the p-value when all the 6 samples are included.
So
Um,
should we put the socks back on and then take off one of the shoes?
Sure. That was a good test. If you remove variable 5, the p-value goes down. Actually, if you remove any of the other ones, I wonder if I need to put that back over there. Clear contents.
So, for example, I put the socks variable up and then I took off variable 3 and the p-value went up to 0.448. So is the question just asking does it always go up when only one group is removed? It seems that way, right?
If you remove variable 5 and then put socks, well, you don't actually have to put, just remove variable 5, it goes down.
Oh, does it? Okay. So that just proves it then.
Yeah. Proof by contradiction.
Yep. Okay, so false. Okay. What is the highest p-value you see when removing only one group? You will need to compute an ANOVA for each possible option.
All right, so what's the largest p-value we get?
So far, when I took off, okay, let's see. When I took off 3, right now I have 0.448. I think that's in the lead so far because
Yeah. 2 is not better. 1 is not better. 4 is not better. And 5 is not better. So yeah, seems like removing variable 2. Is it 2 or 3?
It was 3.
3. Yeah, removing variable 3 seemed to pump it up a bunch.
Interesting. Okay. So
that's 0.448. Is that what you got?
Yeah. Yeah. Okay.
Okay. All 6 are used. Okay. It says when all 6 samples are used, what is the minimum smallest variance? So that looks like it's 27.201.
One sec. I need to put C back there. Okay, so you said 27 point what?
201. Is that what you have?
Where?
So if you look at descriptive statistics,
Yeah.
over there, it shows the variance for each of the variables.
Okay.
So it's asking what's the minimum variance. So which one of these is the smallest?
Mine says 27.208 for 3.
Uh-huh.
But you said 201, right?
No, 208.
Oh, 208. Okay.
Maybe I said it wrong. Sorry.
So yeah, that looks like it's the smallest, 27.208.
All right. When all 6 samples are used, what is the maximum variance? So 53.158.
Yes. So is that just saying that that one is more spread out? Like it's
Yeah, so it has that certain group has, yeah, the data are more spread out.
okay.
Which makes sense because when we removed, because number 3 was the one that we removed to get the highest p-value, right?
Yeah.
And it was the one with the least amount of variance, and so it was the one that was bringing them together more. That makes sense.
Gotcha.
Is that kind of?
Yeah.
So I would assume
Kind of.
if we removed number, what is that, 4, we'd probably see the least change in the p-value, or the low. That'd probably be the lowest
least different.
p-value.
Yeah. That makes sense. Okay.
I guess.
And then it says the test for equal variance is satisfied for these data. I think so, right? Because it's not more than 4 times the smaller variance. Or is that something else?
No, that's right. I was just seeing, is it not more than 4 times? So this
Right.
divided by that. Oh yeah, it's 1.9. Okay, yeah. It's satisfied.
Okay. And then construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots.
I feel like we should have done this before we did all this work.
Yeah. Right? Okay.
Okay. So let's do a QQ plot. Oops. Let's see. Do you remember how to do a QQ plot?
It's one of the spreadsheets they let us have. It does it.
Is that the descriptive statistics one?
I think that might be it.
Loading it up. Yep. That is a histogram. Oh, QQ plots. There we go.
One of the sheets. Jeez. Okay.
Oh.
Are they way off?
Yeah, variable 1 looks way off.
I'll do variable 2 and see how that looks.
Except these are pretty large variances, it seems like. I'll do number 3.
Okay. Now for this, whoa, this one looks terrible too. It's just all over the place.
Oh, we have to sort column A from lowest to highest. I don't know if that changes it though. That's just gonna make it look better, I think. Let's see.
How do you sort it?
Like something. How do you do this? Oh, there it is. I don't know how to do it on yours.
Oh, okay. It's fine. No worries. Did it change it at all, or?
Oh yeah. Okay, that looks a lot better now. Yeah, here, I'll show you what I'm seeing so you can see what's going on at least. Dum-dum-dum. All right, is my screen starting to come through?
No, it's still just your picture.
My picture.
Yeah.
Oh,
I don't know.
that is weird. Well, I guess I'll stop doing that. Can you see my face now?
No.
How about now?
Still not.
Huh. All right, well, when I did that, it made the data look a lot more normal.
Interesting. I wonder why that is. Like, wonder why
It's
it
probably because
matters.
it's graphing it in the order that it is on the spreadsheet, and so if it's out of order, then the dots don't end up getting in the right spots.
Okay. Yeah, good thing we read those instructions, or we'd have said they were all like
Way
not
off.
normal. Yeah.
Pay special text. Okay. I'm going to take that and say alphabetize. All right, so 3 and 2 are actually pretty good. There should be you might look around and see if you can find the alphabetize button. That's what I use, is alphabetize.
Alphabetize. Okay.
Put it in descending order. It has like an AZ with an arrow pointing down is what the button looks like. I think it's the same on Windows.
Is it under like any of the tabs like home, insert, page layout, formulas, data, review, view?
Mine isn't, but I think yours is, and I think it might be on home, but I'm not sure. Whoa, hey. Oh. That was weird.
I hit the arrange button and it did it in ascending order instead of descending order.
There we go.
Did you get it?
Yeah, yeah.
There.
Sweet. So awesome. Okay. Yeah, so I did 2, and 2 looks fairly normal, right?
Yeah, I thought it did.
Okay. Now for these, is there any rule like, oh, you have to have at least 30, or is that just
Not for these that I know of. There's no size limit.
okay?
I mean, it'd probably be good to have some type of. All right, I'm on variable 6, and I haven't found any that are not normal, or at least fairly normal.
Yeah, 6 looks pretty normal too.
All right,
I mean, yeah, they just had us go through all of them just to say true. Each missing is approximately. Yep. Okay. So the test statistics for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left? It's the right.
Yep.
Because it's right skewed, right?
Yeah, so you're supposed to always go right.
Cool.
Sweet. All right. There it is.
Got 100. Oh wait. Awesome. Well, Jason missed out this time.
I
The applause wasn't for him missing out.
know. For him missing out.
It was just timing.
Oh, wrong drum.
So we have an exam this week.
Woo!
Yep.
Yeah.
It seems like I've been having a ton of those recently. Like
Like midterms or something.
yeah.
That's weird.
All right, man.
All right. Hey,
I'll
thanks.
see you Thursday.
Okay, sounds good. Talk to you later.